This is an example of a quadratic application question. It says a rectangular field is 300 yards by 500 yards. A roadway of width x yards is to be built inside the field on all sides. See the picture here on the right. This problem concerns the region inside the roadway. So it says write the length and width of the region as functions of x. So we'll call it, for the length of x, we'll call it maybe L of x. And the length right now, we can call the 500. So it's 500, but we're subtracting x. But we're not just taking away one x, we have two x's, one on each side of the field. So the width of the field would be represented with 300 minus x, or minus 2x. Doesn't matter which one we use, the 300 or the 500 for the length and the width, because those parts are interchangeable on a rectangle. What is important is that we continue to have the 2x. So then, since it's a rectangle, we know that the area of that region would be found by taking the length times the width. So in this case, we're going to take the length function and multiply it by the width function for part B. So the area function, or a of x, would be equal to 500 minus 2x times 300 minus 2x. Now that's not in standard form. If you wish, you could distribute those terms out and simplify it. It says to predict the area of the region inside the roadway if x is equal to 10. So to find a of 10, what we can do is say, all right, that's 500 minus 2 times 10, which is 20, and multiply that by 300 minus 2 times 10, which is again 20. So that's 480 times 280. Which gives us a total of 134,400, and that's square yards. So that gives us a nice big field. For D, it says what is the widest the roadway can be and still leave 100,000 square yards in the region. So that means that the area this time is 100,000. In this case, it would probably be easier for us if we did actually multiply out the different pieces. So we have 500 minus 2x times 300 minus 2x. So if we multiply out the terms on the right side, 500 times 300, we get 15 with 4 zeros behind it. And then we'll get minus 1,000x and then minus 600x, so that's minus 1,600x, and then plus 4x squared, giving us a nice quadratic equation. If we want to now get all of the terms on one side of the equation, get it equal to 0. So if we take 100,000 from both sides, we're going to get 50,000 minus 1,600x, and then plus 4x squared. So now what I would do is rearrange terms and divide everything by 4. So 4x squared divided by 4 is x squared. If we take 50,000 divided by 4, we're going to get 12,500. So that's our constant term. And then 1,600 divided by 4 should just be 400. So we get minus 400x. So now that we have a nice quadratic, we can try to factor that quadratic. Well, these are really big numbers, so you may end up using the quadratic formula. I'm going to actually go ahead and use a program to run this. The quadratic equation would say that this would be 400 plus or minus the square root of negative 400, parentheses squared, minus 4. Sorry, hitting the button there on the pin. Minus 4 times our a, which is 1, times our c, which is 12,500, all over 2 times 1. Using the calculator to do that, I get two possible values of x, so 365.83 or 34.17, approximately rounding to the nearest hundredth. Now again, if we look at this, we have to recognize that the width is the limiting factor here. or did we call it the length? Well, the width was 300. Therefore, that value of x is not possible because we can't take away more from the road than there is room on the field. So that would tell us that the widest the roadway could be is 34.17 yards. And that concludes our quadratic example.